Hi, Algebra students. Here are your notes for section 7.7 on factoring special products. Today we're going to look at a special product pattern, affectionately referred to as dots. Dots stands for the difference of two squares, and here are some things that you need to look for. So anytime you see a problem that is a binomial, meaning that it's two terms, we want to look for, are the terms being subtracted? And then most importantly, is each term a perfect square? Okay, so those are the three things you can use to identify a difference of two squares pattern. So let's take a look at some examples and see if these are difference of two squares. So in the first one, I'm looking to see, is it a binomial? Yes, it is. Are the terms being subtracted? Yes. And lastly, and most importantly, are both of the terms perfect squares? And they are, so therefore, yes, this one is a difference of two squares pattern. Let's look at this second one, 3x squared minus 4. So first, is it a binomial? Yes. Is it being subtracted? Yes. Is it the difference of two squares? Well, 4 is a perfect square, but the leading coefficient 3 is not. So therefore, no, this one is not a difference of two squares pattern. It is not factorable. And again, the only time you can factor something out of a binomial is if it has a GCF in both factors. So no, this one is not factorable. So let's look at the third one. Is it a binomial? Yes. Are the terms being subtracted? Yes. Are the first and last term both perfect squares? Yes. 4 is a perfect square and so is 1. So that one is a difference of two squares pattern. Let's look at x squared minus 7x plus 9. Is this one a binomial? No, this one is a trinomial. So even though it is factorable, it is not a difference of two squares pattern. Let's look at the next one, 4x squared plus 16. This one is a binomial. It's two terms, but does it contain subtraction? No. So therefore, it's not the difference of two squares. Even though the first and the last term are perfect squares, it's not a difference. And then the last one here is 16b squared minus 25. Is it a binomial? Yes. Does it contain subtraction? Yes. Are the first and the last term perfect squares? Yes. So therefore, this one is the difference of two squares pattern. Okay, so we're going to look at how to factor. How do you factor the difference of two squares? And there's a couple important things that you need to know here. First of all, the reason it's important that you're able to identify the difference of two squares is because this is the only time, meant to write something different. This is the only time that two binomial factors the only time a binomial will factor into two binomial factors. Let's write that down so we got it. Only time a binomial factors into two binomial factors. Okay, so that's really important to remember because like I said, otherwise, if you're looking at a binomial, it's either not factorable or the only thing that you can ever take out is the greatest common factor. So you always want to be very aware of this pattern. And then the other thing that I just wanted to remind you of is when you are factoring, when you look at your binomial, remember to always look for a GCF first. Okay, so let's go ahead and get started. So our first one is x squared minus 4. And again, you can see it is a difference and it has two squares, so it looks like it is factorable. So go ahead and get your puzzle pieces in place. So it's a difference, two squares is always going to factor into two binomials. Okay, and it's always going to be, let's just write it this way. This is probably a good note to add also. It's going to always be one sum and one difference, okay? So first term, only one way to factor x squared, and that is into x and x. So that's our first term. And then when we factor 4, we're looking for the factors of 4, which are 2 and 2, okay? Perfect square. What do we square to get the number 4? 2 and 2, okay? So one is going to be a sum, one is going to be a difference. And the reason we know, and I don't know why I just wrote both of those as addition signs, because I just said one is a sum and one is a difference. The reason one is a sum and one is a difference is why this is a binomial and not a trinomial, is because if you check your outers and your inners, you'll know that you get, or you'll notice, you get positive 2x and negative 2x, which cancels, which is why there is no middle term making this a trinomial, because the middle term just cancels out and you only have term A and term C. All right, so let's look at the next one. So in this one, factors of 4g squared are 2g and 2g. Factors of 1, square root of 1 is 1, so 1 and 1. So this one factors into 2g plus 1 and 2g minus 1. Okay, looking at this last one here, negative 16b squared plus 25, you might be thinking, well, this one is not a difference, so it doesn't follow our dots pattern. But remember, anytime your leading coefficient is negative, you should always start by factoring out a negative 1, even though there are no other common factors. So we want to factor out a negative 1 here, and that leaves us with 16b squared minus 25, which now is the difference of two squares inside of the parentheses. So you have to continue factoring this further. Remember, you want to factor completely. So when you factor out your negative 1, don't throw it away. That is still one of your factors with your two remaining binomial factors. And then this factors into 4b plus 5 and 4b minus 5. Okay, so some questions for you really quick, and I kind of already explained a little bit of this, so this is just really clarification at this point. What do you notice about the first and the last term in the two binomials? And hopefully you're noticing that you're always seeing the square root of the first and last term. Okay, so the first and last term, like in the middle problem, the square root of 4g squared is 2g. Okay, the square root of 1 is 1. In the last problem, the square root of 16b squared is 4b. The square root of 25 is 5. So it's always going to be the square root of the first and last term. And then I said, what do you notice about the sign in front of each number? And notice in every single one of these problems, we have one sum and one difference, okay? So this is called our sum and difference pattern. Actually, I think I was spelling that correctly. Sum and difference pattern, okay? So to give you kind of an algebraic representation of this formula, anytime you see the difference of two squares, a squared minus b squared, it's always going to factor into a plus b and a minus b. Those are going to be your two binomial factors. So I want you to go ahead and try the last four on your own using the shortcut, okay? No work really need to be shown here unless you need to factor out a GCF. Always look for that first. But try these last four on your own and we will go over them in class together. And then also bring any questions you have to class with you. Thank you and have a great night.